So today methods, next week introduction, and well, abstract. I think we can do it on our own. And the last meeting, what we didn't do in previous years, we may sketch letters to the editor. And, I'll talk about it later when it will be time for it. Basically, it's repeating most impressive accomplishments, and I'll share the templates. Okay, so today.
And did you make decisions which journals are you going to submit these papers? Same journals, or no? Each of them are going for different.
What do you mean same?
For instance, part C, physical part C, or no?
Yeah, Journal of Physical Chemistry C is like expected target form, but if at some point we see that the paper can have chances in a better journal, then we can rethink. But let's plan on Journal of Physical Chemistry C.
Okay, very good.
So Mead will join us. He submitted his work, and he's really wanting to participate. He's just in the middle of at the end of some other appointment, and he will rush to join us as soon as he can. So I plan to share yes, share screen and maybe tell a couple of words about what is expected in the method section. And Yoon and Aaron are already experts in this activity, so it's for Emir and for Mead if he will be watching the recordings. And I apologize if for repeating these baby steps. It's not new for most of you. The main goal of the method sections in the applied research, like if we are not doing new theory, if it is not a purely method development theory, if we do applied research, then the main goal of the methods section is to enable a reader to reproduce the result, or at least to make an impression to the reader that by following the guidelines from the methods section one can reproduce. So it's reasonable to mention the software. It's reasonable to mention where the atomic models were taken, and often one may need to mention the approximations. So the idea of mentioning approximations was very against my nature when I was writing my first paper as a graduate student, and I was angry at my advisor because he was requesting me like, list your approximations. Why? Come on, I'm doing the best possible thing. But it's a matter of the being computational chemistry and in the computational modeling of materials cannot be done exactly, except maybe hydrogen molecule. So there, no matter what we do, we are not precise. There are some approximations, and in order to enable the reader to reproduce it, maybe with different software, but it's quite natural and adequate to mention what was neglected, what are the approximations. Also, I think this year we do not have very new group members, so the next section doesn't need much of advocating, but just in case, the equations are language of this research area, and it is very appropriate to give them. And the equations are traditionally used to summarize a procedure to obtain observables, to obtain the quantities that were computed for comparison with experiment, the quantities that correspond to real world experiment. And if there are equations, they should be consecutively numbered. If it is, if you do not see them numbered, you may give a gentle suggestion to the author to follow it. And also, there is a unpleasant for authors part of work to make sure that all terms in equations are defined by readers. We can have a unbiased eye and suggest to the authors to define each term if it is missed. So a typical question that a reader should understand from reading is which equations are solved numerically to obtain main results. And if it is not clear, then we can give suggestions to the author. And if you see that any part of the methodology section is not needed, it would be very appreciated to authors if you suggest what can be removed, so that if the main message, if results can be reproduced clearly without additional details, then details can be removed, and both author and future readers will appreciate. And another aspect, right now, it doesn't look like we are doing big theory methods development, but just in case, equations should ideally look like a proof of a theorem in calculus, or they should start from simple to more complicated. Typically, there should be some basic definitions like Hamiltonian, and then the path from first step to the last observable should logically follow as a chain. So if you see it, please give a little compliment to the author. If you do not see it, suggest to introduce it. So there will be 4 pieces, and I believe the one by Mead needs most of work, because it looks like it is his first attempt to write a method section. He was doing a presentation, but on the method, but still, it's he understands what he's doing, but he didn't wrote theory papers in the past. So any suggestions, I believe, will be great help to him. So I see. Bring them up. So this is one by let's see, version. Yeah, this one is by Yuun. This one is by this one is by Mead. This one is by Aaron. And let me check where the one by Emil. No, I think this one is by Emil. So I suggest we spend maybe 40 minutes or whatever it takes to go over and leave some comments. And then we'll whoever ends first please attract attention and check if the rest is ready, and then we'll go and discuss it as we did before. Well, any suggestions or questions on this procedure? Okay, then let me invite everyone to, or if you do not, please confirm if you have access to all documents. Okay, yeah, then let's just focus on reading and reconvene back in like 40-50 minutes. Okay, let me attract attention and check if everyone completed reading or if more time is needed to complete. Ewan, are you done with all reading? No, Aaron? Thank you. Aaron? Done? Amir?
Yes.
Okay. Mid, how many works did you completed reading and commenting?
Read all 3.
Okay. Yep. So let's start in the order they were listed. So the one by Mid first, then by Amir, then by Yun, then by Aaron. So Mid may have noticed some changes compared to what he sent. I made some quick changes before sharing it to group, and let me make a disclaimer. So in the work that Mead has completed, there were no non-adiabatic couplings. It was only optically driven reaction, and therefore the mentioning of non-adiabatic couplings should be completely removed or shortened as much as possible. And second, although this methodology was published, still it is not wide accepted, wide known methodology for the whole community, and some basics of definitions of processes such as Rabi oscillations seem to be needed. We can debate and shorten it, but it needs to be available. Okay, now let's go through the comments. So Amir is asking if there are plans to give references. Probably yes. I can answer it for me. And right now, from original way how Mead formulated it and from comments, including those I submitted, the numbering is not correct. So Mead, please plan on first addressing all comments, maybe removing something, and then renumber all equations in the consecutive order, so it starts like 1, 2, 3, 4, 5. Okay.
Yep. Yep.
Okay. Yep. Thank you. So basically, we'll go over all questions, but basically, what I did while reading it, I gave names to almost each paragraph because maybe we will need to remove some paragraphs or swap their orders. And it seemed to be easier when there are titles. Okay, Amir is asking the word practical. Mead is not responsible for it. I added this word meaning practical versus ideal. Like there are ideal theories and practical implementations. Yun is asking if Mead is computing height of barriers. Mead, can you tell if if you're doing it, if you're planning to do it, or it is just general comment.
Yeah, I was just trying to kind of explain how, well, like fragmentation is occurring by overcoming this. I is there a specific thing that I should be addressing if I use this verbiage?
I believe Ewan was trying to ask, like, if explicit values of barriers are not reported, why to show equation? So just be aware of it. Maybe mentioning of a barrier is not a bad thing, but the reader should understand if you're not computing it, then you are using it only as a general context concept. Just do not, so that you're not getting, you're not trying to get credit for things that you didn't compute.
Okay, so if we explicitly have values, that's when we should be expressing equations.
Right.
Okay. Thank you. Yep, I needed that clarification. Thanks.
Uh, so Ewan makes a comment that there are redundant things. So I think, yes, the beginning of this subsection and end of this subsection repeat each other. So try to, when you will be implementing changes, try to go over and exclude any redundancy.
Of course, yep.
Yeah, thank you. Uh, for selected area here, you would suggest to remove because in your work non-arithmetic coupling is not practiced. If you really think to use it, maybe it can be moved to introduction, and maybe one can tell that computation of non-arithmetic couplings according to the is discussed in the left this and that. But I'm not sure if it is needed. So consider if you need this paragraph, subparagraph. Um, concept of density matrix in specific basis. Then general comments how it evolves in time. Then, so I understand myself that right now it is not an ideal arrangement, but maybe through like after mid consolidates all comments, it can be shortened. And if all participants of the meeting do see what can be removed or what can be shortened, please give suggestions. So the next paragraph is definitely needed, but I'm not sure if it is needed in so extended way. The readers of the paper who are focused on applied aspects could be not aware of the Rabi oscillations, and it's a right place to remind them. And this equation at the end of this subparagraph gives how it should evolve in time in the ideal case, without any calculations, without any practical computations. And without this statement, the practical thing in the next paragraph that Mead is introducing looks like it is flies in the air without a fundamental background. So the equations that I'm highlighting right now are approximations for the one shown here. And without fundamental building, without foundation, could be unstable. So while rewriting was considered to match them.
Yeah, for clarification, once again, the blue is just could be condensed down into some form, but it does need to be expressed somehow. Okay.
Yes. And I believe if you request additional help from me or from Yoon, I think we'll be very happy to assist. But so right now all components are there, but it is a little longer than typical method section in a paper. I'm not sure that this sentence is in the right spot. It could be moved somewhere or completely removed. This Newton's equation with force depending on the electronic configuration of the main equation. And then Jeroen suggests to remove, shorten, or move to supporting information the following discussion. So, Mead, would you share your argumentation why a detailed explanation of how mass spectra are computed are needed in the methods?
My reason of inputting it was I wanted to incorporate everything and then use our previous methods of other sections of we're going to get rid of the things we don't need. And so in my case, I just kind of read one specific paper, used that information, and adapted it to our paper. And that was my initial mindset. And so now I'm on the second stage of if it's needed, great. If not, we can get reduce. Particularly with mass spec, it does seem to maybe not this long equation, but it does need to have some explanation since we are showing calculated mass spec. So going back to your comment earlier today, is if we calculate something, we should probably show an equation of some sort related to that mass spec. So
here is let me share the vision. So on one hand, there is an opinion in the community that a method, an equation that has been ever published shouldn't be repeated again to protect the copyright and just give reference. And in this aspect, since it is not new, it was already published, there is an option to skip it and just give reference. And I think comment of Jeroen prompts this point of view. On the other point of view that Mead just verbalized right now, anything which is plotted needs to be explained. And I was coming into this paradox, into this complicated situation many times, and here is the possible way out. So of course shorten, but still give some equations and give a disclaimer. So although it is known and published method, see reference this and that, in order to keep clear definition of all things that we are discussing, we reproduce some basic steps.
Yes.
Jeroen, would you be fine with such approach? Because if we skip all equations and just give reference, it will be not possible to understand what is going on, and we cannot demand and ask a reader to download and read other papers, especially if they are not in the free access. So it's kind of, we want to help reader to get through. Okay. So here Ewan gives a similar comment. He asks if it is necessary. I'm asking maybe it could be considered to move in SI section, or maybe just give a use it with a disclaimer. Here is the suggested plan. So for me, even if you plan to move some parts of this method section into supporting information, please make a little stop in between, renumber all equations before you move anything to supporting information, and share it with me and Yun to give it a quick read through, so that we can give you a few more suggestions.
Yeah, relating to your last section that you wanted to edit, I mean, it seems like these two are, I know they're addressing to, the mass spec in general. I could condense all of this information to a quote unquote more condensed form and just reference all of this material I have shown here in the SI supporting information.
Yep. But if your calculations show literally this mass spectrum, then this equation seems adequate. And then the rest of equations are needed only in the extent they needed to interpret, to understand what this equation gives.
Okay.
Okay. And here are I think this is computational details, which should be also a subsection. Are there any additional comments or questions to me? Or suggestions or feedback or encouragement? Okay.
I do have one question. So, like looking at Dr. Hahn's method section on his paper that we're reviewing, that seems very almost simplified in some manner.
Right now it is slightly different types of sport. It's like hockey and figure skating.
Okay.
So what Dr. Khan is doing is different type of competition. There is an attempt to submit to letter style journal, which have very hard limits on the number of symbols. And as a main developer of the method, he already practiced explaining the methods, and it's he would put equations in a similar style as you are trying to do now, but in the letter style paper it is not allowed. They like allow maybe 3,000 symbols total or so.
Thank you for clarifying. Yep, I get it.
So please take Dr. Khan as an image and role model in many things, but not in style of the paper, because he's doing a short letter and you are doing full size paper. Okay?
Yep, thank you.
Yeah, thank you. So second is by Amir. Okay. Let's agree to use uppercase for ions. It was lowercase here, probably it was a typo. Here it was ionic charge distribution, which is not right, it's electronic charge density. Equation 2 is really great, and it really deals with how WASP software is working. In fact, it computes this C coefficients rather than space distributed wave function. But definition of each symbol used in this equation is needed. Like what is K? Is it vector or scalar? What is G capital? What is G cut? Please, Amir, please try to.
Sure, I will double check. And
okay. Homo and Wuma were not defined and used. Maybe you plan to define them in the introduction, but just in case, try maybe define them here.
Sure.
Again, double check if this potential should have index k, if it should depend on k or not. I'm not 100% sure, but I would check.
I will do it.
Electrons with ions, yes, but by some reason this is not highlighted when people are talking about it. Maybe again, double check. Maybe in different sources place interaction with ion as a separate term here, and then do this potential that refers only to electronic interaction. So I put plus, and here is 1 over interaction with ions. But just explore how it is typically explained in other papers.
Okay.
Okay. I suggested to move the explanation of hybrid right here because it is more foundation rather than observables. So it is please approve or discard this change, but I do have an argument that it looks much better here.
Sure, I will keep that.
Then also density of states, like apples to apples, should look they look better together.
Okay.
So I have an idea what you are doing as involved in the paper, but if I read it for the first time, it's a little bit confusing with momentum or wave vector. From one equation to another, it changes from scalar to vector, and it is not clear whether you explore momentum dispersion in all 3 Cartesian directions or only in one, so or in z direction. So just try to be clear. Here you have d sub k, and here you have e sub k vector. The picky reviewer will pick it.
Okay. I will check that.
So later I'm going to jump forward by 3 equations and then return back to speak about this delta k equals 0. So interestingly, in your equation 11, for transition dipole and for oscillator strengths, you have 2 indices for orbital number, initial and final, but you have only 1 index for momentum. While generally, if there are transitions from 2 orbitals, each of which has index and momentum, there should be like 2 orbital numbers and 2 momentum. So I believe this happens because of this approximation. So delta k equals 0. But this should be highlighted.
Sure.
Otherwise, having 2 indices and 1 is inconsistent. How the model was obtained. So I assume it was prepared by drawing based on chemical structure. So it was not imported from X-ray diffraction, right?
I think so. Actually, I just gave you at the beginning of this project last year, actually, just initial XYZ coordinates. I think you did this work.
Please try to explain the source of the model, or even if it was modified and re-optimized, where the original model was taken. So is it made by a human, or it was a literal measurement from?
So we can say that, for instance, we draw that in Material Studio.
Yes, yes. Okay. Do not hesitate. It's fine. Just to avoid confusion and do not claim the credit that doesn't belong to us.
Okay.
Because nowadays many people borrow exact structure from X-ray diffraction, and if it is done so, it needs to be mentioned. Okay. Any other comments or suggestions to Amir? I think there are no other
Thank you for your time.
So the one by Yvonne. And it's really high quality writing. I think one needs to make an effort to be picky and find any suggestions. So maybe here it should be reference, and it is all correct, but it is so short that a reader who is not doing calculations of this kind may need maybe one more sentence for general context. The stuff that Mead was doing with too many things here can be just briefly just so as a reader, I would like to see a highlight what were the main observables. So if the goal of this calculation is to find intermediates or their energies or their masses, it should be highlighted. Maybe the goal is different. Just I do not claim, I do not require this specific observables being highlighted, but just a statement, what was the main practical goal as a help to understand. And are there any other places in this document that relate to the methods? Okay. Yeah. And Amir is requesting references right in the method section. Many thanks. Are there any verbal questions or suggestions?
That was completely fluent for me to follow this section. I think Dr. Han did a very excellent job.
Mir was requesting more equation, but I believe I refuted his previous. Okay, and so now we should go to the work by Aaron. Oh, from the very last figure, last line, the figure 7a is really revolutionary. It's really strong, and we all in the group will try to follow Aaron in that. But your revolutionary findings are not highlighted neither in captions nor in methods. So maybe you can be not so shy and highlight this thing. If let me bring attention of everyone. So all of us who were practicing dynamics of electrons and holes up to today were considering that number of electrons and holes stays the same during the computed process. So the thickness of the yellow stripe, which is distribution of electrons as function of energy with time, stays the same. And amount of holes also stays the same at each time slice. And what Aaron did, he explicitly included recombination. So at some point of time, electrons and holes recombine and disappear. So there is nothing, and there is no electrons, no holes, and the system actually comes to the ground state. So after this logarithmic time equals about 5, system really comes to the ground state. And the reason for this approach is to give additional certainty to the protocol of computing photoluminescence. In everything we did before, the integrated time-dependent integrated photoluminescence was using integration over the whole area definition with length of trajectory being a manual parameter that we set up voluntarily. And if a system relaxes to homo lunar and we extend this period like 10 times or 100 times, then it will artificially increase the quantum yield of photoluminescence. So it's kind of controlled by artificial parameter, which is not good. Here, Aaron includes recombination, and then the result of integration over time, and therefore the height of the photoluminescence peak, are independent on the length of trajectory, if trajectory is long enough. So if we make this logarithmic time equal 5, 6, 7, which means like 1,000 nanoseconds and so forth, the spectrum will not change. Okay, done with. Sorry for taking time and advertising. Maybe after we are done with papers, we can do a group meeting and try ask Aaron to share codes. But let's go to the.
I have a quick question.
Please.
So if there is recombination, then why the expectation value is not changed?
Because the expectation value of electron in hole is normalized to number of electrons. So we find expectation value of energy and divide it by total number of electrons. And if you give the same thing, even if number of electrons approach 0, it does not look as natural. I would, as a user, as a reader, I would appreciate if this 2 lines converge to each other, something like that. But I'm not sure if one can design such procedure. So if it would be a classical process where energy of HOMO and LUMO goes down, then it would happen. But here, the energy of HOMO and LUMO stays the same, but they yield 0 occupation. They approach 0 occupation. So I understand this little feeling of confusion, and I feel the same. But by the procedures, we are getting this like bare line without it's like stick of lollipop without candy itself. Okay, we should go over the equations. Unknown Windows user suggested to add space. I don't know who is it. I'm asking why it starts from equation 5 and other plans to mention equations 2 or 4 somewhere. I hope yes. And since one of the key aspects of the paper are polarons, some equations of their definitions could be mentioned. Please double check equation 12. I may miss, maybe I misunderstand something, but to get an angle, one probably needs some inverse trigonometric function.
Yeah, I think that was lost in translation.
Okay, yep. And should it be subtraction over scalar product or opposite? Because cosine as an overall thing to the power -1 and inverse cosine are two different things.
Yeah,
Just
it is.
double check. Maybe I'm wrong, but I would put it this way as inverse cosine are cos of scalar product divided by distance or distance. Let's postpone this discussion if needed, but and I need to look on the version before this transit. Is it right this number of bonds is time dependent?
Yeah.
Okay. I think things were lost in transit for this equation as well. So there something is wrong. Instead of equal, should be like vertical line here and there, right? Okay. And let me double check. Maybe there is something about this recombination. No, I think the recombination should be in the details about this dissipative term. And here is the indirect trace of this thing. So if this I and j are home and room, and with time they approach equilibrium value, then contribution to spectrum with time will decrease to 0. And integrating for time after they are recombined will not give any new contribution, so it will converge. So Yoon would like to hear clarification about charge balance to open the gap. To my understanding, like I know what was done, but as it is explained, it sounds like a cheesy way to feed the answer, independent of what are the results. Aaron, can you defend your approach and convince you that it is a legitimate thing?
I guess I don't know exactly how legitimate it is, but I guess with the way that the model's constructed, it's, I guess you can consider it n-doped. So it has electrons occupying the conduction band. So it specifically has 2 extra electrons. So all the valence band is filled, and then there's occupations in LUMO and LUMO +1. So to open the gap, just remove 2 charges, which makes the whole cluster 2+ charge.
So this is the procedure, and there are well-respected references in the community. So we are not the first who are doing it. I don't remember the last name, but it is one of the known computational chemist is doing, and several people. Let me give an argument which is objective, independent of personal consideration. So, and Amir may appreciate this diagram as well. So in the middle, I show the open gap, occupied and unoccupied. And on the sides, I show HOMO is empty, and other side, LUMO is occupied. So suppose we do have structure with given stoichiometry. Suppose we have a solution which has possibility to oxidize or reduce this colloidal quantum dots randomly within some limit. Then those samples which will be oxidized or reduced to a figure that would keep gap closed will not give any optical signal. But those that statistically will open the gap will be seen in experiment. So if we are monitoring optical signal of quantum dots, we will see only those where band gap is open by one or another reason. I see that Aaron accepts this argumentation, but his judgment is biased because we need to do it to survive. You wouldn't do, would you take this argumentation or you see some flaws in it? Okay. Aaron, would you be interested to add some additional comments to justify this this model?
Mm-hmm.
Okay. Yep. And thank you, Yvonne, for bringing it up. We do not want future reviewer to be upset with some provoking statements. So if one just slows down and start with a general statement and then take it as an approximation to focus on a certain class of configurations in the statistical ensemble, then I think we will be safer.
I have another question.
Please.
So for the model, the lead is 2+, right? Bromine is minus. Cesium is 1+. So the overall charge should be +8. But I guess from your explanation, maybe some elements are just radical instead of charged species.
Or it's just a stoichiometry problem. So this ABC formula, that's like the bulk crystal. So that's charge neutral throughout the entire, because it's 3 negative charges,
right?
1, 2 plus, and a plus. But with clusters, they're very non-stoichiometric. So you're going to have, due to the surface, you're going to have excess of one type of species or another. So in this case, we have excess negative charge ions on the surface. So I guess the main, I mean, we could play with the model with like the chemistry to like charge balance it if we wanted to. Without it, you'd have to explore a lot of different possibilities. But the one we have was symmetric, so we chose symmetry over exploring the very wide possibilities of the charge neutral models.
Okay.
And one more argument: if we for you. If you take as an example computational modeling of metal-organic complexes, they are typically cations. So when it has metallic cations, some ligand shell, but overall charge of is non-zero. And instead of explicit counter ions, often one just adds charge and multiplicity. One doesn't tear off the ligand because it will break the symmetry of ligand field splitting. So playing with charge is more safer and will give a more correct description. And I think playing with charge instead of trying different radicals originates from the same philosophy. Okay. What is the rationale to use these values?
The next one. Yeah, so for at least one time step, you can plot the where the first coordination peak saturates. So it integrates up to, say, I don't know, 5 nanometers, and then the peak kind of plateaus until it hits the next coordination sphere. And these values correspond to the midway points between first coordination sphere and second coordination sphere.
Yeah, maybe this brief explanation can be added. So let me thank everyone. I really need to be in the class in the other meeting starting from this minute. So many thanks for inspiring collective editing. Authors, please consider to implement changes. And let's focus on the introduction section next Tuesday.
Thank you all. Thank you for your comment.
Okay. Many thanks. Have a nice weekend. I look forward to emails and any other communications.
Thank you. Bye.